Okay, check this out. Okay, okay. Forget one dimension, which is a dot, a point of reference. Two dimensions, which is any dots occupying two planes of x and y. And without going into any more math than that, which is irrelevant for my purpose, you have depth. Yes, depth. So you have right, left, up, down, and forwards and backwards. Now in 3 dimensions. Now in 2 dimensions, you lack depth. So any object that you say, anything that is representative of any solid, definite, geometric figure, you know that it is a representation of that geometric figure, and that is why you know what its dimensions will be, such as a cube. Say, on 2 dimensions, on a piece of paper, you draw a cube. You know how to do it. It's 2 squares and lines attached, whatever. You know it's a cube, but if I say it's not a cube, then it could be like a little tiny front square, right? Just bear with me, I'm trying to... And then in the back it could be 30 miles away and 10 miles wide, but because of the closeness of this so-called camera, yeah, right? Then the front looks big, like you have your thumb up to your eye. It looks huge, right? And you put it way back there, and then it's small. Okay, so the analogy is crazy, but, you know, still. The fact is, when you lack formula on paper, you can define 2 dimensions accurately, given a measurement, and you can say how wide something is. But if you represent a 3-dimensional object, then you imply distance, and unless you can define exactly what something is and tell someone this is definitely a cube, you won't know how far away one side is, right? Same thing in 4 dimensions when projected or implied in 3 dimensions, like 3-dimensional paper, so to speak. When you draw a 4-dimensional object, the representation, and if you rotate that in 3 dimensions, it'll start to look funny, like you would if you rotated a cube. If you find a cube on a video somewhere, just observe it and, you know, cover one eye, do whatever you need to do, but imagine it as a drawing and be like, oh, okay, I see. It's like, you know, you look at a cube anywhere, a box, and it's like, okay, this got straight sides everywhere, and, you know, no big deal, but you look at it in a video, it's like, okay, the one side is right. That's kind of the same thing, but the difference is all 4 dimensions is a 3-dimensional object kind of superimposed on itself. So what you have is backwards. It's like if you look at a tesseract straight on. Oh God, I wish you could see what I see. Imagine every angle that you see as right, as a right angle 90 degrees. Every single angle you see in a hypercube, a tesseract representation, is a right angle. And you're like, no, but that's moving, it's changing. Shh. No, it's not. But the thing is, your perception of it is much the same way as if it was rotating on paper. But it's the same size. If you were to stand in the middle of one of the 3-dimensional kind of pockets, so to speak, it's like standing in the middle of a square on paper, which you draw a cube. You rotate that. Something like that. Okay, I'm done trying. I figured I would give it a shot because I'm bored.